this is it, this is what I want to do. And it's a great feeling to know what you want to do. It's not just a job, it's part of your life. If you enjoy doing that, you're going to want to spend more time doing it. I'm Ken Teeter. I'm an assistant professor in the Department of Molecular Biology and Microbiology. We work on plant and bacterial toxins, and we examine how these toxins enter the target cell. The toxins begin outside of the cell, but they have targets within the cell. So they have to get in the cell in order to function. And so we look at that process. And if we can understand that process, then we can develop therapies to disrupt the process. If we prevent the toxin from getting into the cell, then we prevent the toxin from harming the cell and harming the patient as a result. Well, one benefit of undergraduate researchers is they're productive. They generate data for the lab and they help the projects in the lab move forward. They bring a level of excitement and enthusiasm to the project. And they also bring basic questions that we take for granted. When you start with a new person in the lab and you start from the ground up, you begin to reassess your assumptions of the project and reevaluate that. So you get to see your work in a new light through the eyes of your student.
I'm Liz Haynes, and I'm a molecular biology and microbiology major at UCF. I actually knew a little bit about finding an undergraduate research mentor from the UCF Honors Program. And so I went in and I looked at the binder they have, and it's full of undergraduate research mentors who are actually actively looking for students. The first lab was a biology lab, and I got into that and I volunteered a little, and that gave me a little bit of confidence, like, oh, research isn't so scary. And then I got a reply from Dr. Teeter, and Dr. Teeter had already found a project for me to work on, and I was so excited that I would have a project that would be solely my own, and plus it was in an area that interested me. Alright, my research is on immunotoxin. What immunotoxin is the combination of a lethal toxin along with an antibody. Now, the binding site of an antibody is very specific, and it will specifically target surface molecules on cells that we tell it to, such as cancer cells. It'll find those surface markers and attach to it, and the cell will then get a signal to take in the immunotoxin. Now, the toxin is going to kill the cell, which is good. It's a cancer cell, we don't want it. But there can be some instances where that's bad. For example, if you're administering the immunotoxin via IV, it's going to encounter the cells of your veins, and the cells of your veins are going to accidentally take it up. And that's called non-specific toxicity, and we want to prevent that. So we think that we can prevent that by using lipopolyamines. Now, lipopolyamines are commercially available, but we think that we can build a better one. And we've worked together with Dr. Fansteel on campus to create a lipopolyamine that we've shown actually increases the toxicity by 20 times when we use it along with our immunotoxin, and we believe that we can make a better cancer therapeutic this way. I came in as a sophomore, and I only had a background in, chemistry 1 and biology 1, and so it was really scary to come into a lab where everyone knows so much more than you.
It's not just them alone in the wilderness, they're immediately part of a family, part of a group. The graduate students, the postdocs, the PIs, we spend so much time in the lab, we see more of each other than we see of our family. Research, like anything else, takes practice. You don't walk into a lab and belt out an experiment right away. It's just like anything else. It's like playing the guitar. You don't pick up a guitar and play Stairway to Heaven the first time you pick it up. You have to learn the chords, you have to practice, and you have to get good at it. It's the same thing with research. You come into a lab and the new students are unskilled, they don't have the hands or the experience of bench work, but that's something that develops over time.
It only takes maybe a month and a half to learn what you really need to know to do your experiments. And once you've got that down, it's really easy to just start picking up everything about your project. You just want to know more about it, and you want to know all aspects of it. And you have such an appreciation for your project. It becomes your baby.
She's working on the project independently, generating her own data, pursuing her own ideas related to the project.
Any setbacks that I've had, Dr. Teeter has been very understanding, and the most important thing is that he tells me where I went wrong and he explains it to me, and he always tries to get usable data out of things even when I think they went wrong.
I'm kind of like a human global positioning device. I GPS system for the lab. I provide the map, the project, and I provide the directions of how to get from point A to point B. But it's up to the student to actually get there. Now, if they get off course, if things don't go right, then they can come back to me. I can put them back on course.
I knew I wanted to do research, but I didn't know how far I could go. And that's really the exhilarating part of it, is having all of these possibilities ahead of me. And UCF's really prepared me for that.